I can't remember. Where's your schools? Where did your school stop at? Magnetism. So the electromagnetism hasn't been started. Okay. Okay. But did they ask you to do any self-study? For which topic?
All the topic.
Oh.
Like
So did they also ask you to study the last chapter, radioactivity? Oh no, that one is not easy. That one is not easy now. Electromagnetic induction? Did they ask you to self-study?
that the topic after this.
Yeah.
After this, go.
Oh no, that one is not easy too. Okay.
Sorry, my wife is in good form.
Okay, tell you what, I think for today, I don't want to go, maybe I'll go into something new if there's time. But other than that, I want to concentrate on what you have studied so far for magnetism, electromagnetism. I think overall, personally, I don't think this is a very difficult topic. But just revise one concept with you before I let you do the worksheet. Because sometimes it's not a current. Instead, you see something like this. Okay, so let's say I have this situation. You will have a magnetic field. Okay, Ethan, in this case, your magnetic field is pointing into the screen or out of the screen. Okay, good. So you have a magnetic field. This common question, actually very common. So if they tell you there's an electron moving in this direction, once it goes into the magnetic field, how is the force acting? What is the direction of the force acting on the electron? Aligning is
Downwards, right?
downwards, downwards,
Yeah, downward.
Okay. How do you manage to use your left hand to figure out? And because what's the direction of the current? Yeah, left to right. So this is how you should use your left hand. That is the current. Okay, so by right, the force will be downwards. Therefore, the resultant is it's going to move like that. Can? Because there's another force acting on it. No, this. Don't forget you have the original force here. Then you have a new force. So this is the resultant. It's going to move. What do you call it? Southeast or whatever you call it. Okay. Just remember this. Surely you'll come up something like that. Surely. Okay, so, but of course, just one additional point. Obviously, maybe I cancel. Okay, obviously the force is only, it's going to keep acting, so it's going to move. But once it's outside the magnetic field, it will become a straight path. Can take note because outside the field, there's no longer any additional force. Okay, can. Okay, let you try these questions. They are not particularly hard. If your concept is strong, shouldn't be a big problem. So it combines magnetism and electromagnetism.
Nine times. Okay, do you see any signal on the wall? 178 and 0.178, is it the same numbers?
No.
Not the same number, but it's similar numbers, right? Similar numbers, right?
Yeah.
What's the difference?
There's a technical point.
Decimal place, right?
Yeah.
So this one is 0.178. So what's the difference between these two numbers? What's the difference between these two numbers? You count the difference. How does 178 become this? Yeah, 0 something, but your decimal place for this is 178.0. So right now this number is actually 178.0. This one is 0.178. There's a difference. How do you move the decimal place? Very easy. You know how do you move the decimal place?
Me? The please push me.
Move the efficiency.
Oh, it's so hard.
It's meant for you to. It's meant to be hard. So how do you move the decimal place? No. Multiply. Okay. So if you want to move in front, we divide. Square. Square. In order to move the decimal place to the left, that means you move to the left. So that means it will become, let's say 1.8 there, right? This is divide by 10. So you divide by the total number is either 10. So you either divide by 10, 100, 1,000, and etc. So it's basically all multiples of 10. So you divide by 10. So how do you make the decimal move all the way? In this case, your decimal is in front of the 1, right? That means it's 1, 2, 3. How do you make it move 3 spots? You got to buy. One has 3 zeros. Yeah. So you divide by 1,000. Then you'll get 0.178. That means here is divide by 1,000, right? But if your left hand side and your right hand side stays the same, your 1,000 is going to go somewhere else, right? That means this blank, one part of it is already 1,000. A blank, one part of it is already 1,000. Okay, so now the next part, 39 and 3. Are they similar? No, right? All right. So how do you make these two the same? You make them same? 39 and 3, right? What is 3? What is 39? So how do you find that? 39 divided by 3 is? Something like that. One step at a time. Very often. You close already correctly, what do you mean?
13.
13, right? That means here 13 also goes missing. Basically, because 39 divided by 33, right? So that means your 13 is somewhere here on the floor. So it goes into your blank also. So now you got time 13. Why you times here is because to this way is divided, right? So what you need to find here is the times multiplied by. So it's 1000 multiplied by 13. So what's the answer for this? What's the answer for the blank? Yes, the answer is 13,000. Yeah. Then now look. In paragraph 50, today we need paragraph 50.
You want something to see?
Or you will get I think you will better do only right. You need a picture.
Yeah.
You look initiative.
Yeah.
Then you Pernah nggak kamu mau bersama? Belum enggak. Pernah nggak kamu mau bersama? Kami sekarang sudah di ini kalau sudah dari soal dari kamu.
What was he? You know, he's up recovering. He took the calculator, he closed it, he threw it all the way in the sky, and then on the ground. And it ended up over here, like in this space, and then what the right is your arm. I wanted to go away. But we didn't see.
Nanti pas supaya ini section B ya. Section B ya.
Trying to get this see.
Oh.
Why? Up there.
Dan each ini
Finish.
dan the rest of the whole paper each.
Question 4. When I move them.
Question 1. Iya. Jadi poin. Jadi poin.
So really want to go for B. If I can think you would be.
So it's 100 meters in 74 seconds. Okay. 100 meters in 24 seconds. How long will it take to drop 1.6? So you go 1.6 km. What is 1.6 km converted to meter? 100. Then kilometers to convert 1 km is how many meters? 1 km is how many meters? How many meters? 10. Yes, you would. Who's that coming to the Okay.
You need one. And I look over here.
Go. You can go over there.
Picture, can you get?
Yes. So now then it's how many meters?
Like, B is 1 kilometer, 1,000 meters. So yeah, it's same simple.
Okay. So 1.6 times 1,000 equals to, you convert your km to meters. 1.6 km is how many meters? Can the whole centimeter in a bit? Yeah. Yeah. Do you try to finish? No. Yeah. 1.6 km to 1 meter is. Oh, consider it.
If you want it like hard.
If you know 1 km to 1 is to 1,000 meters, so you need to times 1,000, right?
Yeah. It equals 16,000.
This is 16,000. No. 1.6.
But this is 16,000.
1.6 times 1,000. Don't forget your decimal place is in front, I don't behind. Yeah. So what? If it's 3 zeros, you move the decimal place how many times? If it's 3 zeros, you move the decimal place how many times? No. Here got how many zeros? So you move the decimal place how many times? To the left or to the right? If you move the decimal place to the left or to the right, if you multiply. So you don't move 3 zeros, right? If you move to the right, means you multiply it. So are you multiplying or dividing now? Now it's times or minus? It's times or divide? It's one times, right? Times 1,000. So left or right? Left or right? Left is divide, right is right is times. So left or right? To the right, right? So it's 1, 2, 3. you see there's the up here, there's no number at 1, 0. The bottom one is 0. So what's the answer? If there is two empty spaces, that means there's another 2 zeros there. So now what's your open number? Oh, I think there's zero down. You're removing a decimal place. Remove a decimal place, meaning the answer is 1,600. Okay? 1,600. First, we find how many seconds it is from the first. Well, it's 100 meters in 24 seconds, right? Good complicated, but what's the total distance? 1,600 meters, right? Right. So how many times of this we multiply? How you do is you take total distance divided by time, the time in second. This is not 50,000. It's 1,300. Don't say 1,500. 1,300. Yeah.
Divided by 100.
16, right? So it's 15 times. So now, to find the total time that you go, 24 seconds, 400 meters, right? So it's 24 times 16. Why times 16? Because there is 16 sets of 100 in 1,600. Now, you go and you go and by there is 16 sets of 100 meters. Right? And each set of 100 meters, you take the total seconds. So, find the total time to go. 24 seconds from 16 sets of 100 seconds. Right. Now you press this one. Equals again. Equals. Equals again. 1 minute is how many seconds? How many is how many seconds? How many is how many seconds? How many is it? 50 seconds. How many 50 seconds? So then this one, right? You need to find the minute. So it's 384 divided by 16. So what's 384 over 50?
That do you see?
384 over 50.
I'll give you One or one. Turning to
Okay, for now, press this button. Safety, please repeat.
1 4 seconds.
Yeah,
So that's right.
yeah. So you don't press it, you need to stop again. Yes, 24, 5. The kind of thing that for me. It's not like that. It's not okay. But it's not okay. So that it's not okay. It's okay.
There's a big oh, there's a big now. You can see that again.
So it's the same thing, like you try to read question 4 part B. Try to read question 4 part B, you think the same thing. Here's the number 4 part B. If I have no one, right.
I was like words.
So to understand each of the line, see what the finding. And
So what is it really? Is it
the part B.
One question, how many percent is it?
Yeah.
Yes. Why you didn't ask me?
And go.
Picture you It's not anything. I watched the film. No, not the book. No, I mean real. Because it's single. No. I just keep on moving.
If I choose not to correct that, or you want to look at this? So can question 4B below
I never what is correct.
before A for you.
Ooh. So, English or Spanish?
Don't say.
And I don't know what. Okay.
And
Just check it out.
how many did you look at last?
Huh? Wait, I thought you were doing it.
Another time. Then we finish it watching next week. I'll go into the
Hey, don't wait. Okay. You want it to find. No. Oh my God. Yeah, so. Oh, I made them myself. Actually, but one thing more. One of these. Yeah.
Which part? Huh?
Hello. Hello, girl. Yeah, SCP. But go home then. I say I see. I put it up.
But this environment is not making the products, it's nothing to use. So question 4B, they ask what the distance. So question 4B has asked what the distance you will cover in 3.5 minutes, right? So then, first minute, so what you have? Only 100 meters in 24 seconds, right? Convert 3.5 minutes into seconds. Convert to seconds. 1 minute is how many seconds? 1 minute is 50, right?
Oh no. How much do we know?
Or what do you?
I believe that's called vacuum. 50 lots.
So 3.5 minutes is how many seconds? You're talking 1 minute is 60 seconds, right? So this one times 60. So 3.5 times 60 equal to how many seconds?
Person.
Hmm? 270.
Yeah. Correct. He's doing correction.
410 seconds, right? Then after the at distance cover. Distance cover.
You just go this.
24 seconds is 100 meter, right?
Yes.
So you can do 410 seconds divided by 24. So what does the to find the number of steps of 100 meters that you can run? The number of times 100 meters you can run in this amount of time. So 410 divided by 24 is. Sekarang kita pakai calculator. Sekarang kita pakai calculator. Apa?
Wait.
Kita limbo di calculator. I'm going to hear you. What was one change after the change for one way between? Is it on two?
35.4. Oh, that's over.
35 over 4, right? But it's 35 over 4. Wait, second. Is it 35 over 4 or is it 35 over 4?
5 over.
So it is, right? So 35 over 4 steps. So 35 over 4 steps of 100 meters. So you how to find distance covered? 100 meters times 35 over 4 equals to
Wrong.
what's your answer?
The girl said if he can replace the calculator.
Well,
I don't remember. Nice.
but in July, go there.
Yeah. Good job. Then I actually need it. What? Next question. Yeah. Yeah. Ah, but anything wrong? Ooh. Thank God. Not wrong. It's Wait, I didn't realize that you're like, oh, wait, I'm very talented.
Yeah.
Yes,
Good.
I'm very talented then, but then. Oh,
So to get why 100 times 35 over 4.
175. Oh, I know it's not like.
175 meters is. I got myself. Eh?
It's not a long ratio. It's never a ratio.
I mean, beautiful.
Yes. Ratio this. This. Then what? This. Or just one. Then what? No. The extreme. First sheet. No, first alpha. No, it's alpha 4. The first alpha and then the extreme. Why is this not like this?
Many person coming. Although one you say me. Yeah.
And what?
Copper in magnetize.
Ah, okay, you forgot. Answer is no. What are the 4 magnetic materials you need to remember?
Iron, steel, cobalt.
Yeah.
These crystals, there's one P attracted to it, although it's a copper.
This one is trickier. So you may want to note this down. Okay, let me show you.
Question 9 is
Actually, it's not tricky, just that you need to think a bit deeper.
So again, 0.6 as a fraction is convert to a fraction. 100.6 as a fraction.
Okay, come, let me ask you.
0.6 as a fraction.
If I have a coin like this, everything is the same.
Then you'll give you the single fraction.
Now, Ethan,
5 half.
just a coin without any core, does it have a magnetic field?
They say you have 0.6.
It has, huh? Alright, so that means the copper core does not matter at all.
So the point is,
Yes, the coil is produce its own magnetic field.
This one, and then give 3 of the remainder to his friend. Yeah.
Wait, question number.
Q is
The remainder.
Stronger than
iron is iron is soft.
iron is soft, right? So soft means what?
Easier to
This one, so
So in general, iron will be stronger.
remainder.
If all the conditions are the same, then iron will be stronger.
He had in the end and fraction of the number at the start.
when the current is the power still be stronger.
When the current is off, what happens to the iron? Will the iron still be magnetized after the current is off? Okay, we are talking in general. So iron easy to magnetize and demagnetize, right? So that means once the current is off, iron will lose the magnetism almost immediately. But still, it retains some. In fact, it can retain all its magnetism at least for the next few seconds.
What is 6 over 8? That's the remainder, right? So, okay, very simple. This one is 3 over 5, right? This one is 2 over 5. Then out of the 2 over 5, he has 6 left, right? Okay. So, very sure.
One, two.
How more mouse at the end? So they got 2 units, right? But it's divided into 8 parts, meaning that 1 unit chair is 4. It's 4 parts, right? So the total is how many parts? If 1 unit is 4 parts. 1 unit, so 4 parts, right? How many units is there here? 5. So 5 units equals to how many parts?
One, two, yeah, one, two. Yeah, we want to do second C. Do second C.
4 parts, 5 units is. If 1 divided it,
Milliampere
that's
is
5.
the power of magnetic.
4 times 5 is
Milli 10 to the power minus 3.
20 parts.
That one must
So
remember.
the total is 20, right?
Milli, micro, they come out all the time.
How much does he have left? A mouse 6 over here, right? So the number of mouse he have left is 6 parts, right? Right?
I got it. Sure, I got it.
One.
The answer is 5.
So the remaining
Yeah,
fraction,
question 3.
the fraction of in having at the end versus the total is 6 parts over 20 parts. Right? If you simply cross 9, Ayat. Sorry, I'm not taking this five. It's five because there's the remainder of five. Sorry. You only got 8, right? If you try to eat, the remainder here is 5. Okay, it's 5 over 20. 5 over 20. What should we go to the com? The total to go.
But this big world and the they want to because the first thing to this is to speed. What is the
And probably when you ask, it has 75 hours and half.
right?
When you make 0.375 only. Well, you see, here is the number of hours you have left over the total, right? I mean, if the 0.25 of total equals to, how many over here? 75, right? 75, correct? Okay, 75. 75 hours, 0.25, right? How do you make this keep it simple? 0.25 fraction, 1/4, right? I only need to make it for 1. So 1/4, how do you make it a 1/1?
Okay, I think quite doable, right? Except for maybe the last few questions.
You don't need that very complicated, right?
Okay, let's get through. Hopefully, almost every question is correct.
Is
Okay, Ethan, number 1.
how much does it left? How many parts?
You said A.
Yeah.
At point P of using a larger current in the opposite direction. Larger current means field strength increases. Opposite direction means the field direction reverses. Huh? Make sense? Doesn't it need what?
You can get magnetized.
Demagnetize, but they didn't really mention about magnetization or demagnetization, no? Because they didn't even show you any core. Is there any metal core?
Oh.
No metal core. So it doesn't matter. I think even it comes back to the point. Even without a metal core, the magnetic field is still there. But why do you need a metal core then? Or what, let's say, why do you need an iron core? Let me repeat. Without a core, that field is still there. The field, there's a magnetic field. But with a core, how is the magnetic field different? You may want to write it down in your notes somewhere. So let's assume this one doesn't have a core. But if I, assuming the wiring is still the same, I put in an iron core.
When despite the multiple of 20, if you multiply 5 by 20, then you can just do that directly. So 20 times 5 times 5 equals to 20. Alright, and
Okay, so assuming everything is the same current, actually same number of turns, even though I didn't draw that accurately. Of course, your direction of the magnetic field will still be in this direction. Yeah, correct. Okay, but what is different is this. Now you have a lot more magnetic field lines, especially through the metal core. It must be a magnetic material, of course. So basically, if you want to explain, you'll be writing something like this. If your core is made of magnetic material, it concentrates the magnetic field lines. But let's go further than that. It then what happens when you have concentrated magnetic field lines? It means yes. But I'll use the full term magnetic field strength increases. So you have a stronger magnet. It can be up to 100 times stronger. Make sure you get this concept. Number 2. When seen from above, first thing, if you understand the question, that means your eye is here. Okay, you're looking down from above. Use your right hand grip rule. Which finger is your current? Yes, good. So you should see as a clockwise, right? Clockwise. Oh, okay. Yes. Can you just highlight this? What does it mean? It means that as distance increases, the strength decreases. They become more dispersed. All right. Okay, try to highlight this. I know it's a tricky question. Okay, let's go on 3. See, very good. 4.
You find 3 units first, right? So you find this
5.
It is more part. How do you find this more part? But you have 4 parts.
6.
What do you have here? You got 3 parts, right? Got 3 parts here.
Is it B or D? D.
19.35. I think it's 4 parts equal to how much? You went on Newton. Okay?
It's the same concept as the first question.
No,
1.
I think you didn't look at this second part of the question. Do you notice this part? Which statement describes how the steel bar can be demagnetized?
That's all. They increase the current.
3 to 1 to 4.
Like,
So, well, any number like this is right.
that's it.
Always make it 1 part. Then
Okay, but use an AC supply and gradually decrease the current in the circuit. Gradually increase the current. But what I can say is at some point you have to take up. You have to. Okay, all I can say is at some point you have to stop the power supply also, right?
Yeah.
So, I think a more reasonable answer is you want to decrease the current. I know the question is not very, very clear. Because it will slowly be demagnetized, so it doesn't matter at the end. The magnetism left is very little. And then at the end, you just turn off the current. Seven? E4
Well, we'll spend $6.
Okay, good that you get this right. Number 8. Yeah. Okay, good. 9.
C.
Okay, good. 10. Okay, look carefully. Direction of electron flow, so the current will be opposite.
This is our mindset, right?
Oh, people.
That's my lesson. Because you're really man. If you're
I used the wrong hand.
Ah, wrong hand. Okay. Try not to do so. Yeah, no choice. You really have to remember that. Okay. Because the right hand is used of something else in the next chapter. 11. It is the same. Yeah, the same question.
how to find it is we need to find how many times of it.
This one is more important is what are the words you use to answer it. So how do you explain?
iPhone has been magnetized by the current is
That is another. Okay.
the south pole of the iron core is facing the south pole.
Yes.
So like that. Like poles repel, it doesn't permanent magnet fields away.
Okay. I think that's fine. No. Do you say clockwise? Actually, that one is a bit redundant because whether clockwise or anti-clockwise depends on where you're looking from. You won't be penalized, but it won't be useful either.
And you 6 over 7.
How about B?
But
Iron rod attracted to the iron core. Iron is an
so actually this 6 units, they're both equal. So however, actually, not probably.
Maybe in
You actually only need 7 units. Whereas the other has 10 units over 1, right?
Okay, I think more or less you get it, but I just want to be sure. I want you to include these words in your answer. Make sure you mention iron is magnetic material.
Albert?
Because technically speaking, they don't use the term magnetic object, just magnetic material. Okay, that's the first thing. Second thing, make sure you have induction in your answer somewhere. All right, so the south of the solenoid. Did they use solenoid? Hold on, let me see. What did they use for the coil? Okay, the south of the coil induces the left of the triangle rod to become north.
You have 7 units, Albert has 10 units. What's the difference? How many units difference?
And of course, roughly,
Unit, right?
which is what you have already written over the whole section.
How much is it? Because different, the 3 units is 64.
But anyway, maybe I've
They ask you to
mentioned too much, but essentially make sure you use magnetic material in your answer. Induction must be somewhere, and of course, opposite poles attraction.
Just all together, all together, there's 4 units.
Doesn't the iron rod get attracted regardless of pole?
Yeah,
Albert?
the iron will be attracted regardless.
Albert plus U equals to 10 plus.
But you still have to write the use all these terms magnetic material, induction, opposite pole.
So, find 17 units. 3 units equals to this.
Next one, number 2, your arrow is
17 units straight by drawing.
you didn't draw.
Program
Yeah, but
54.95 divided by 3 17.
downwards.
Yeah, okay, good. Should be downwards. I'll try not to lose all these marks. Okay, 2 ways to increase magnitude.
Stronger magnet and increased current.
Okay, fine. I think, yeah, no big deal. You should know all this. Okay, 3. BC arrow.
And this is
Pointing from right if left to right.
That's the right. Hopefully you don't forget to draw this in. Correct? Partly.
ET downward and 3D is not.
Okay, make sure you draw them correctly. Yeah, I think nothing much to say here. Why is there attractive force?
Based on the right hand, the direction of the current determines the direction of the magnetic field. Since current is flowing through the solenoid, the iron core is a magnetic object, and we induce a magnet. The iron core will gain magnetic properties and attract the iron ball.
Okay, I think that is fine, but let me just double check. I think that is fine, except that I would prefer you to add something in. Ethan, let me take a look. Right hand, what's the full name?
Right hand grip.
Try to use the full name. Try to.
X was multiplied. So X was multiplied by 8. But now I am applying.
Then you'll be induced to the magnet. Okay, that is still fine.
X was multiplied by 8. Then added 47.36.
But the point is, you are missing something. No? I'll tell you what you are missing. Actually, you're not wrong.
47.36. After the result was divided by 5. The result was divided by 5.
In this diagram, it's quite clear cut. You can determine which side is north, which one is south. Tell me, where is north, where is south? Or the iron core.
Remove the fraction. If you have magnetic field fraction, remove the fraction. Okay? So
Basically, the iron core is north.
Yes, good.
then the left side you down, the right side you.
Okay, so I want you to include the bottom end or the end facing the iron ball becomes north.
You bring the 5 over, you need to times. And so it becomes x times 8 plus 7.36.
But what else is missing from your answer? I'm not saying your answer is wrong, but something else is missing.
Unlike both the track.
Yes, but I also want you to add in the end yes on the iron core. Try to use the same words as given in the question. Iron core and iron ball induces the side or the upper surface. Let me be more specific. To become south.
Okay.
And then yes, you add in opposite poles attract.
Next step, you do the multiple, you do the plus first.
Right,
You
can.
do plus first, you do plus first.
Okay, thought what is the effect on the magnetic field in the iron core? Will describe the effect on the force between core and the ball. So you need to have at least 2 points. One is on the magnetic field, the other is on the force, magnetic force. So you answer that.
What's the direction?
Okay, good.
Strength will gradually.
Sorry, what about the magnetic field strength?
You're gradually decrease.
Minus 49.36.
Okay, come. Ethan. You don't look at it in this manner. That means you look at it in terms of, let's say the batteries are switched over. Circuit is still closed. That's the situation you want to look at.
No change.
Yeah, no change in magnetic field strength of the iron core. But how about the force between iron core and the ball? Why? You already said that magnetic field strength of the iron core is the same. So will it induce the same magnetic field strength in the iron core?
If you multiply by 8, what's opposite of multiply?
No.
Okay. Let's backtrack a bit. This is the core, right? Core has the same magnetic field strength, agree? Except the magnetic field direction is reversed. Will it induce the same magnetic field strength in the iron core?
Divide by 8. What's the answer?
Yeah.
You should, right?
Yeah.
So what happened to the force then? Yeah, unchanged.
0.6, what divided by 8?
The force will still be the same.
Decimal. What's that?
But of course, even though you don't need to include your answer in your mind, make sure you realize that this guy becomes south, and of course this side becomes north, and of course this side becomes north. But the question didn't ask for this, so you can leave them out. But in your mind, you should know this. And otherwise, the force is still the same in magnetic. Actually, in direction also. Okay, look at C. Do you still remember how to solve this? How many?
8.9
meter per second. I can't remember a little bit. What's the energy conversion?
It's down.
Okay, I think that's fine. 8.9. Where's the... I can't remember the answer. Yeah, 8.9. Okay, good. All right, good. Let me just type it down first.
Copy your question 5 on, then go to the next question.
Okay, this kind of questions can definitely come up. Why iron rod is always attracted to iron core, but the force of the bar magnet varies? How did you answer this?
I use the formula P equals to IR. So I use R is constant. So when P is positive, I is positive. When P is negative,
Okay.
when it is present, it's actually every magnetic object is respective to the current. Based on right then group rule, the presence of magnetic field, iron core is the iron core is induced to become magnetic always attract magnetic object using the iron rod. So current alternate.
Current alternates. Okay, fine. Go on.
The current alternates the direction.
18.
The form of the iron core will change rapidly.
And
You will attract the
and you got the magnet plus
and slight force without
18.
attract. Hence, the force on the magnet will vary.
18 cm times 2 over 8 because the increase is 2 over 8, right?
Okay. Again, same thing. Just be a bit mindful. Just now you used the term magnetic object, right?
Yeah.
Yeah. Iron rod is a magnetic material.
And I have to state the induction also.
Yes, the iron core induces an opposite pole in the iron rod.
Okay, then the new graph. New graph equal to
Even if I try to use the same words, iron core, which is used in the question, iron rod also used in the question.
so minus.
I think overall it's okay, but let me double check whether there are any like small errors.
You know I'm 1 over 5. That's the increase. That is the amount that either increase.
But to tell the truth,
Okay. So if it's increased, then you add.
the part about the current positive negatives, that one actually can remove, is redundant, even though it's not wrong.
And the next question. So,
I need to be part one.
wait,
Exactly.
so the length area equals to length times breadth. The length is 34.75, right? Times breadth, which is now, so what's the answer here? The time you know is copying question 5? That's you. Good. Okay. You know copying question 5? You not copying?
Okay, I don't know how strict they want to be in this case. Because, of course, everything you've written is not wrong. How about this one? They mentioned about the force, right? Actually, what aspect of the force is varying? What aspect of the force varies? Magnitude, does it change? But you look carefully. What's the voltage? This is, I don't know, what, 5 units? 5 units, whatever this units are. This is also 5 units, right? So does the voltage magnitude change? It doesn't, no? Yeah. So they may want to be very strict about this to get the 4 marks. So you may want to be specific. It's the direction of the force that changes between attraction and repulsion.
Are you looking for some validation?
But if you want to be really precise, then you may add in magnets, but the magnitude, not magnetic. But magnitude is constant. Okay, so these are all the small things that sometimes you have to look out for. Okay, look at number 3. Why there's a turning effect? Okay, before that, have you found out what's the direction of the force? AB?
Downwards.
Okay, good.
Okay, good.
Alright, so how do you explain there's a turning effect?
Direction for the current is
Law
based on the next like if force on line is acting downward.
Okay, good.
The force acting outward. Hence, the finding of an anti-clockwise turning effect on the coil.
Okay, I think that's fine, but let me double check. Like, overall, it's fine. The only thing is the direction of current is in anti-clockwise manner. What do you mean? Even if it's A, B, C, D, is that anti-clockwise?
What's the difference in these two? The difference is the increase in area, which is the difference. Okay.
It's not anti-clockwise, Okay. So mistake like this may penalize you. In fact, you don't even need to add that in. Just make sure you mention the force on AB is down, CD up. Okay, that creates an anti-clockwise turning effect. Okay, yeah, that's all. Oh, but sorry, I forgot something. If your marker is very strict, because you look at the question, if you can remember, you want to add something. Because they did specify A, B, C, D now. You may also want to talk about BC and AD. Any forces? Yeah, no forces. Okay. If you can remember, include those as well. If you can. Alright, because sometimes they want you to work very hard to earn those 3 marks. Look at the last one for A. Which one is iron? Which one is copper?
So I think iron core is one core.
Okay, why?
Iron is magnetic field that can be magnetized.
Right.
So this one is literally 1/10 equal to 0.1. Say
The magnetic properties of the magnetized iron affects the field.
because we need to read the question.
Copper is not magnetic, so it doesn't attract any piece. If one piece is attracted to the coil.
Yeah. Actually, you know the, I mean, you know the answer, but let's use what I mentioned earlier, right? Basically, the iron core concentrate the magnetic field lines. Okay, the short form, I use a short form magnetic field lines. And of course, it creates a stronger magnetic force. It's only 2 marks, so I don't have to write induction and all those nonsense. Creating a stronger magnetic force and attracting many more pins. But you want to talk about the other guy too. Of course, you're right. Copper is not magnetic.
Oh.
So the magnetic field is solely due to the coil. Creating a weak magnetic force and so attracting only one pin. Actually, it's only one pin. Yeah, that should be good enough to get you your 2 marks. Oh, how did you draw this?
We finish this
You
topic.
One is 8, one is
The cost of the sticker in
And
dollars.
the other one?
How many stickers did you
Oh,
buy?
okay. Let me see. And
How many stickers did you buy?
8. Okay, can.
How many stickers
As
did you
long
buy?
as it's less than iron core, 8 is fine. In fact, when the current is off, you can still put 8.
How much is it?
Because let's say it's only 1 second, it will still retain that magnetism, no? But of course, they did not specify how long was the current off. So it could be 1 minute later, then yeah, possible, maybe 6. Yeah, as long as less than 8. Or the same as 8.
Oh,
Okay, you get this?
Yeah.
20 ohms, yes. Should be easy.
Now,
Replaced by another coil, thicker wire. Okay. How do you explain part 1?
The second core will have a larger area. Resistance will the resistance will decrease.
Okay, good.
As
Go on.
resistance decreases, current increases.
Good.
More current will lead to a stronger magnetic field.
Okay, very good.
Hence, strength of electromagnet will be stronger.
Okay, very good, very good. You cover all the points. Good. That you mentioned area, cross-sectional area. You mentioned about resistance. You mentioned about current, good. And of course, magnetic field strength. Okay, good. I think that's all. Nothing else I want to add. Last one?
Voltage rating of the battery.
Okay, can. Anything else? I know they asked for 1, but anything else?
Say other. I can say length of 1.
Okay, can. What else is very important?
Number of curves.
Yes. Okay, number of turns of the coil. try to use turns because I heard from all the schools they don't like to use number of coins because there's only one coin, but it has many turns. Seems that way. I know primary school they teach you differently, but try to stick to this number of turns. Okay, any questions for today? So just highlight all those things I asked you to highlight, just in case they come up. Okay, I say that this chapter is not particularly difficult. The next chapter will be more difficult. Okay, I think that's all for today.
If the A is a bigger number, the problem number half of the list is the same.